Imagine waking up in a city where the air is crisp and clean every single day. The usual rumble of city traffic is replaced by a gentle, futuristic hum. Buses, cars, and even delivery drones glide silently along the streets, leaving behind nothing but a tiny, harmless puff of water vapor. This isn't a scene from a science fiction movie. This is the incredible potential of a city powered by hydrogen. We are standing on the edge of an energy revolution, a shift that could redefine what it means to live in a modern urban environment. This future promises not just technological advancement, but a healthier planet and a better quality of life for all of us. In this future, energy is all around us, but it's clean and seamlessly integrated into our lives. Rooftops might not just have solar panels, but also compact systems that use that solar energy to create hydrogen fuel right at home. Local refueling stations looking sleek and high-tech would be as common as gas stations are today. These stations would be the heart of the city's energy network, providing the clean fuel that powers our transportation and even our homes. The dream is a world where powering our lives doesn't mean polluting our skies, and that dream is getting closer to reality every single day. Think about how this would change our daily experience. The smog that often hangs over big cities would be a thing of the past. The health problems associated with air pollution, like asthma, could decrease significantly. Our cities would not only be cleaner, but also quieter. The loud engines we are so used to would be replaced by silent, efficient electric motors running on hydrogen fuel cells. It's a complete transformation of our urban soundscape and atmosphere. This isn't just about swapping one fuel for another. It's about fundamentally rethinking and redesigning our cities for a sustainable and healthier future for generations to come. This vision is ambitious, and it requires us to solve some very big and very interesting engineering puzzles. Creating a vast network of hydrogen production and storage facilities is a massive undertaking. We need to ensure that this entire system is not only efficient, but most importantly, incredibly safe. The journey to this clean energy future is complex, but it is one of the most exciting challenges that scientists and engineers are working on today. It's a journey that will require innovation, collaboration, and some amazing new technologies, including a new workforce of robotic helpers ready to keep our future safe. So, what makes hydrogen the superstar of clean energy? It all comes down to some very simple science. When you use hydrogen in a fuel cell to generate electricity, the only byproduct is water. That's it. No carbon dioxide, no soot, no harmful pollutants that contribute to climate change and smog. It's the cleanest fuel imaginable. Hydrogen is also the most abundant element in the universe. We can produce it from various sources, including water, using renewable energy like solar or wind power. This process, known as electrolysis, gives us a completely green energy cycle, from production to consumption. However, with great power comes great responsibility, and hydrogen is no exception. While it is an amazing fuel, it also presents some serious challenges that we must respect and manage carefully. Hydrogen is the lightest element, which means it is very difficult to contain. It can escape through the tiniest of cracks that other gases wouldn't. More importantly, hydrogen is highly flammable. In fact, it can ignite much more easily than gasoline, and its flame is nearly invisible to the naked eye in daylight. This combination of being hard to contain and easy to ignite makes safety the #1 priority in any hydrogen system. These properties create significant engineering hurdles. We need to design storage tanks and pipelines that are perfectly sealed and incredibly strong. The materials used must be resistant to something called hydrogen embrittlement, a process where hydrogen atoms can make metals brittle and prone to cracking over time. Every valve, every seal, and every connection in a hydrogen system must be designed and maintained with an extreme level of precision. Any failure could lead to a dangerous leak, and a leak in the presence of an ignition source could lead to a serious incident. Overcoming these challenges is key to unlocking hydrogen's potential. The sensitivity of hydrogen means that even small, local refueling stations are complex and delicate operations. They are not just simple pumps. They are miniature chemical plants that handle a high-pressure, flammable gas. They require constant monitoring and precise maintenance to operate safely. The pressure inside a hydrogen storage tank can be incredibly high, up to 10,000 pounds per square inch. Managing these pressures safely day in and day out is a non-stop job. This is where the need for something more than human oversight becomes crystal clear. We need a solution that is tireless, precise, and immune to human error. For a hydrogen station to work safely, it needs constant attention. Human workers have been the backbone of our energy infrastructure for over a century, and their expertise is invaluable. Technicians are responsible for performing regular inspections, checking for leaks, calibrating sensors, and replacing worn-out parts. These are highly skilled jobs that require intense training and focus. The work is demanding, and the environment can be hazardous. Workers must follow strict safety protocols, wear protective gear, and be constantly aware of the invisible dangers that hydrogen presents. They are the frontline guardians of our current energy systems. However, relying solely on humans to manage these sensitive environments has its limits. People get tired, they can be distracted, and even the most skilled expert can make a mistake. In a normal workplace, a small error might not be a big deal. But in a high-pressure hydrogen facility, a single overlooked detail, a loose valve, a miscalibrated sensor, or a tiny undetected crack could have catastrophic consequences. The potential for a leak or an explosion is always present, making the job incredibly stressful. We are asking people to perform flawlessly in a high-stakes environment, 24/7, which is a very difficult standard to meet. The nature of hydrogen itself adds to the difficulty. Since hydrogen gas is colorless, odorless, and its flame is nearly invisible, a leak is extremely hard for a person to detect. Technicians must rely completely on sensors to tell them if something is wrong. This creates a situation where a person's natural senses are of little use, making them dependent on technology. If a sensor fails or gives a false reading, a human operator might not know there is a problem until it's too late. This is a significant vulnerability in a system that demands perfect safety and awareness at all times. Furthermore, some maintenance tasks are simply too dangerous or too delicate for a person to perform while the system is active. To do certain repairs, a station might need to be completely shut down, vented, and secured. This downtime is not only expensive, but also inconvenient for customers who rely on that station for fuel. We need a way to perform maintenance that is safer, more precise, and can be done without causing major disruptions. The limitations of human intervention highlight the urgent need for a new kind of worker, one that can operate in these hazardous environments with superhuman senses and unwavering precision. This is where smart robots come to the rescue. Imagine a team of highly specialized robots designed specifically to maintain and protect our future hydrogen stations. These aren't your typical factory robots that just repeat one task over and over. These are sophisticated mobile machines equipped with an incredible array of advanced sensors. They can see in infrared to detect the heat from a nearly invisible hydrogen flame. They have ultrasonic ears that can hear the high-frequency hiss of a gas leak long before a human could. They are our robotic guardians, built to perceive the dangers we can't. These robots are designed to be the ultimate safety inspectors. They can tirelessly patrol a hydrogen facility day and night, in any weather condition. Using their advanced sensors, they can scan every pipe, valve, and tank with incredible detail. They carry laser scanners that create precise three-dimensional maps of the entire facility, allowing them to spot even the slightest physical change or deformation in a pipe that might signal a future problem. They can also use chemical sniffers that can detect hydrogen molecules in the air at concentrations far lower than any human could ever notice, providing the earliest possible warning of a potential leak. Beyond just detecting problems, these robots are also equipped to perform delicate maintenance tasks. They can have robotic arms with specialized tools to tighten valves, replace seals, or even perform complex repairs in areas that are too dangerous or cramped for a person to reach. Because they are machines, they can be built to withstand extreme environments. They are not affected by toxic gases and can operate in explosive atmospheres where a single spark from a traditional electronic device could be disastrous. Their bodies are made from special non-sparking materials, and their internal electronics are completely sealed and protected. The goal of these robots is to create a system of constant, vigilant oversight. They would work around the clock, collecting data, and ensuring that every component of the hydrogen station is operating exactly as it should. They can perform their duties with a level of consistency and endurance that is simply not possible for humans. This frees up human workers to focus on more complex problem solving and system management, moving them from dangerous frontline tasks to safer, more strategic roles. These robotic guardians are not just a convenience, they are an essential layer of safety for our hydrogen-powered future. What makes these robots truly revolutionary is their brain artificial intelligence, or AI. The AI allows them to do more than just see or hear a problem. It allows them to predict and prevent failures before they even happen. The robots are constantly collecting massive amounts of data, from temperature and pressure readings to vibration analysis and acoustic signatures. This data is fed into a powerful AI system that learns the normal operating heartbeat of the hydrogen station. The AI can then identify tiny, subtle changes in that heartbeat that might indicate a developing issue, like a valve that is starting to wear out, or a pipe that is under unusual stress. This predictive capability is a game changer for safety and reliability. Instead of reacting to a leak after it has already occurred, the AI can alert human operators that a specific component has a 90% chance of failing within the next week. This allows for proactive maintenance, where the part can be replaced during a scheduled safe shutdown before it ever becomes a danger. This shifts the entire maintenance philosophy from reactive to predictive. It's like going to the doctor for a checkup that can tell you not just how you are today, but what health problems you might face next month, giving you time to prevent them. When compared to human capabilities, the advantages in speed and accuracy are astounding. A human technician might take several hours to manually inspect a complex network of pipes. A robot can do the same job in minutes, scanning every square inch with sensors that are far more sensitive than human eyes and ears. When a repair is needed, a robot can perform it with mechanical precision, tightening a valve to the exact torque specification every single time without fail. This eliminates the risk of human error in critical tasks, ensuring that every action is performed perfectly according to safety standards. Furthermore, this robotic workforce offers significant long-term economic and environmental benefits. By preventing catastrophic failures, these robots save enormous amounts of money in potential damages and cleanup costs. By ensuring the hydrogen system is perfectly sealed, they prevent the leakage of hydrogen gas, which, although not a greenhouse gas itself, is valuable fuel that is expensive to produce. More efficient and reliable stations mean lower operating costs, which can translate to cheaper hydrogen fuel for everyone. This makes the entire clean energy ecosystem more economically viable and helps speed up the transition away from fossil fuels. Of course, this robotic future is still under construction. There are significant technical challenges that engineers are working hard to solve. Developing robots that can operate safely and reliably for years in such demanding environments is a major undertaking. We need to improve battery life so they can patrol for longer periods. We also need to perfect their ability to navigate complex, cluttered spaces and manipulate objects with human-like dexterity. The AI systems also need to be incredibly robust and secure, immune to cyber attacks that could compromise the safety of an entire facility. These are not small hurdles, but they are solvable with continued research and innovation. It is also incredibly important to remember that these robots are designed to work alongside humans, not to replace them. This is a model of collaboration, not automation. Robots will handle the dangerous, repetitive, and physically demanding tasks, the dull, dirty, and dangerous jobs. This will elevate the role of human workers, allowing them to become system supervisors, data analysts, and remote robot operators. They will manage the fleet of robots, interpret the complex data from the AI, and make the final strategic decisions. This partnership combines the strengths of both humans and machines, the robot's precision and endurance with the human's creativity, critical thinking, and problem-solving skills. By integrating these robotic guardians into our hydrogen infrastructure, we can build cities that are not only cleaner and more sustainable, but also fundamentally safer. The widespread adoption of hydrogen energy has the potential to dramatically reduce urban pollution and combat climate change. And this technology helps make that transition a secure and reliable one. It provides the peace of mind we need to fully embrace a powerful new energy source. This is how we build a future where our technological progress goes hand in hand with the well-being of our communities and our planet. We are standing at a pivotal moment in history. The technology for a clean energy revolution is within our grasp, and the promise of a healthier world is on the horizon. The fusion of hydrogen power and intelligent robotics represents a powerful step forward in this journey. The real question is no longer about what is possible, but about our willingness to embrace this change. Are we ready to build this safer, greener, and more automated world together?